On this 2020 to 2025 F250 with the 7.3 gas engine, P0420 means the PCM may be seeing bank 1 catalyst efficiency below the acceptable threshold. In plain terms, the catalyst may not be storing oxygen the way a healthy high-efficiency catalyst should. The truck may run normally, or it may have a check engine light with no obvious drivability complaint. Broadly, the fault area can include oxygen sensor circuit or sensor concerns, exhaust leaks, fuel control problems, injector or base engine issues, oil contamination, or the catalyst itself. A slight sulfur smell can also be normal on a new vehicle or a new catalyst. Catalysts with less than 8,000-16,000 kilometers, 5,000-10,000 miles, are likely to have a sulfur smell because they are highly active, and installing a new catalyst may actually make that smell worse. Start with the basic system checks. Turn the ignition on and confirm the catalyst efficiency code is actually present. If other codes are present, check what they mean first. Clear the PCM DTCs and repeat the self-test before chasing catalyst efficiency by itself. That matters because catalyst damage is usually the result of something happening upstream. Abnormal engine operation, especially misfire, can drive catalyst temperature higher than normal. Also ask about high oil consumption, because an engine using too much oil can load the catalyst with phosphorus and reduce its efficiency. Next, visually inspect the HO2's harness connectors and make sure the sensor wiring is not crossed. Confirm the correct rear oxygen sensor is connected to the correct connector, because crossed rear HO2's connections can make the catalyst monitor fail. Then inspect the harness for exposed wiring, corrosion, and correct routing. At the PCM connectors, look for damaged pins, pushed-out pins, corrosion, and loose wires. If you find a wiring or PCM connection concern, repair it, clear the PCM DTCs, then run the catalyst monitor drive cycle to verify the repair. Now check fuel pressure. Use caution here. The fuel system remains pressurized when the engine is not running, so treat it like a fire and injury hazard. For a mechanical returnless fuel system, turn the ignition off, relieve fuel pressure, connect a mechanical fuel pressure gauge, turn the ignition on, pressurize the system, and cycle the ignition several times to charge the fuel system. Compare the pressure reading to the fuel system specification used for this test. If fuel pressure is within specification, move on to the exhaust leak check. If it is not, go into fuel delivery diagnosis. Fuel pressure above specification can create an abnormally rich air-fuel mixture, and that can raise catalyst operating temperature. When the diagnostic path calls for the FRP bias checks, disconnect the fuel injection pump connector with the ignition off, start the engine, command fuel mass die, % to maximum, and monitor FRP. One check expects the FRP PID value between 345-827 kPa, 50-120 psi. The next check starts with the ignition off, the fuel injection pump connector disconnected, and the engine running, then compares FRP to FLP. That check expects the FRP PID value within 138 kPa, 20 psi, of the FLP value. If either applicable FRP check fails, install a new fuel rail pressure sensor, clear the PCM DTCs, and repeat the self-test. If the check passes, continue to the exhaust leak test. Next, check for exhaust leaks. Regulate shop air to 34.4 kPa 5 psi before connecting it to the exhaust pipe outlet. Do not exceed the limit. Pressure above 241 kPa 35 psi can damage system components. With the exhaust pressurized, use soap and water to check the exhaust flanges and gaskets, the universal HO2s and its mounting surface, the exhaust between the universal HO2s and rear HO2, the downstream HO2s and its mounting surface, and the exhaust within 15.25 cm 6 inches of the downstream HO2s and mounting surface. Also check the exhaust flange bolts for correct torque and check the downstream HO2s for correct torque. If you find a concern, repair it, clear the PCM-DTCs, and run the catalyst monitor drive cycle to verify the repair. If there is no leak or mounting concern on the catalyst code path, the next step is monitor verification. If the exhaust diagnosis moves into a restriction check, inspect the front and rear exhaust pipes, catalytic converter, muffler, and tailpipe assembly for damage or restrictions. A slight amount of pressure in the exhaust is normal, but excessive back pressure can seriously affect engine operation. If an exhaust back pressure tester is available, install it and follow the tool maker's setup and test process. Typical exhaust back pressure, when measured near the exhaust manifold and at normal engine operating temperature, should not exceed 20. 7 kPa 3 psi at idle and 55. 2 kPa 8 psi at wide open throttle watt under load. If that test indicates a restriction, repair the concern, clear the PCM-DTCs, and repeat the self-test. If a back pressure tester is not available, attach a vacuum gauge to an intake manifold vacuum source and watch the gauge while increasing engine RPM. When the engine is first started and idled, the reading may be normal 51-74 kPa, 15-22 nhg. But a clogged exhaust system can make the needle slowly drop to 0 kPa 0 nhg. If the vacuum gauge indicates an exhaust restriction concern, repair it. Clear the PCM-DTCs and repeat the self-test. If neither check shows a restriction or leak, pause, recheck the earlier diagnostic path, and avoid guessing. Now verify the repair and confirm the code stays gone. Carry out the catalyst monitor drive cycle, then use a diagnostic scan tool to perform the PCM self-test. Keep this separate from the earlier testing. This is where you verify what the monitor does after the wiring, fuel, and exhaust leak checks are handled. If P0420 is still present, the supported repair is to install all new catalytic converters on bank 1. After that, clear the PCM-DTCs and repeat the self-test. If P0420 is not present after the monitor and self-test, the test is complete and no concern is present. The key with P0420 is not to condemn the catalyst first. Confirm the code, handle other faults, check HO2s and PCM wiring, verify fuel pressure, check for exhaust leaks around the sensor locations, use restriction checks when the path calls for them, then run the catalyst monitor and make the final bank 1 call. For more diagnostic training, visit stepdiagnostics.com.